A, -3, -1, and B, 1, 11 are 2 points on a plane. We want to find the midpoint of AB. Well, that's just averaging the x-coordinates and then averaging the y-coordinates. So we're going to add the x-coordinates and divide by 2, and then add the y-coordinates and divide by 2. So -3 add 1 is -2. Divide that by 2 is -1. -1 add 11 is 10. Divide by 2 is 5. Now we want the equation of the line that passes through A and B. So the first thing we're going to need is the gradient. So if I do y2, let's call this one y2, this one's y1, take away y1, and divide that by x2, which would be 1, take away -3. That is 12 over 4, which is 3. So our line is y equals 3x plus c. And we know it goes through A and B. So I'm going to use the coordinates for B here. So the y-coordinate is 11. The x-coordinate is 1. So 11 equals 3 plus c, meaning that c must be equal to 8. So I've got y equals 3x plus 8. Then we want the equation of the line perpendicular to AB that passes through the midpoint of AB. In other words, the point we found just here. So, negative reciprocal, if this one is 3 over 1, turn it upside down, take the negative. The gradient here is -1/3 x plus c. And then we can use this point. So the y-coordinate is 5, -1/3 times -1 plus c. So 5 is equal to 1/3 plus c. Now if we remember that 5 is 15 over 3, we've got to take away 1 over 3. So that gives us that c is equal to 14 on 3. So y is equal to -1/3 x plus 14 on 3. Now we want to write the equation of the circle shown below in this diagram here in this form. Well, we can identify the center of the circle as being just here. And that is at the point 1, -3. And then once we've done that, we can see the radius is 1, 2, 3, 4, 5. And so we get x minus 1 squared plus y plus 3 squared, because it's down here. And that's going to be equal to 5 squared. The function below has this form here, and we want to identify a, b, and c. It's a hyperbola. And one of the asymptotes we've put on, but the other asymptote is just here. So the asymptotes cross just here. Now the fact that that asymptote is y equals 1 tells me that the c is 1. The fact that this has moved to the right here tells me that b is equal to 3. So I've got x minus 3 on the bottom. Now, if you go to the point where they cross and go 1 unit across, we go 2 units up, tells me there's a 2 on top here. So we've got a is equal to 2, b is equal to 3, c is equal to 1. And finally, we have this quadratic here. Now we can see that the turning point here, the turning point there is at -3, 5. And that tells me that I must have x plus 3 squared plus 5. And I just need to work out the value of the a. Now, a nice way of doing that quite often is to find a point like the y-intercept, but we don't have that here. So what I'm going to do is I'm going to do it by going from the turning point. I'm going to go 1 unit across, and be careful with this axis. This is -3, so 1 unit across is 2 squares. And then going until I meet the curve again, and I've gone 2 squares down, and that actually does represent 2 units there. So it's gone 1 across and 2 down, telling me that this is -2. So I've got A is -2, B equals -3, remember to make that a plus there when it's a minus in the original equation, and C is equal to 5.